So as before we have considered complex tissue. In that complex tissue we have seen xylem, which will be responsible or which has a function of transport of water, or rather we consider it as a conduction of water. So another complex tissue, that is phloem. So now we have to consider a phloem, which is solely responsible for conduction or rather transport of food material, and that food material will be transported in plant. Food is going to produce inside a leaf, and leaf will be considered as a source of food. From that source of food to every part which is in a need of food. It means as leaf is considered for production of food, so that leaf will be considered as source of food, and that food will get transported to the rest of the part which are in a need of food, as like root will be there, as like your stem will be there, branches will be there, rather growing flowers will be there, storage in fruit also there. So this food will be transported to this part from your leaf, and as leaf is considered as a source of food, so these part which are in a need of food, we call them as a sink of food. They will be in a need of food, so we call them sink of food. So food will be transported from source to sink, and the food from source to sink, sometimes it get reversed. How we consider it? So why we consider food is a phloem will transport a food in a bidirectional. See, sometimes what happens, leaf will produce food, that food will be stored inside a root, as we have considered in the carrot. So carrot has a modification of root for storage of food. So food will be transported to the root, either from your leaf, and later on at one stage in plant body, leaf will get detached. Either so at the time your that reservoir where you have stored food will act as a source of food. So it will get reversed. So it's your source of food, and the needy one which will be considered where exactly your food is going to store is called a reservoir, or we call it as a sink. So sometime or later when your leaf has been got detached, that time your sink will also act as a source, and from there your food will be again transported back to the rest of the body part. So likewise food will get bidirectional transport. See, first of all from leaf to your root, and in a later stage whenever the plant body will need, or whenever on the plant body there will be no leaf present, that time your store which were initially sink, that sink will act as a supplier. So here we consider food will be transported in a bidirectional way. So because of that food is transported by, as water, unlike water is having a unidirectional flow through the xylem. So this phloem is solely responsible for having transport of food, and that transport of food is in a bidirectional way. So your phloem is also considered as bust. Phloem is considered as bust. Then phloem, as like we have considered xylem as a hydrome, so here phloem is considered as leptome. This term has been coined by, this term will be used for phloem by Gottlieb Haberland. Haberland has used this term, that is leptome. So phloem is also considered as bast fiber, phloem is also bast, and phloem is also considered as leptome. Phloem is used for conduction of organic food from source to sink. Wherever there will be production of food will be considered as source, and wherever there will be requirement of food, so this part will be considered as sink. Your phloem is generally considered as a dead tissue. So why we call phloem as a dead tissue? Because as we have considered xylem as a living tissue, in xylem only xylem fiber will be considered to be dead, and here in phloem only your phloem parenchyma is considered as living. So rest of rather your sieve elements are dead, rather companion cell are also dead, and bast fiber or phloem sclerenchyma is also dead. So only living tissue in phloem is phloem parenchyma. Sieve element, companion cell, bast fiber or phloem sclerenchyma, all these are dead, and so we call this tissue as a dead tissue. So we can call this as a dead tissue. So phloem is considered as a dead tissue, as we have called xylem as a living tissue. So here phloem will be considered as dead tissue. Now, as phloem is a complex tissue, so as xylem was also complex tissue, so there were more than one tissue has come together. So here also the different tissue will come together, and they will form your complex tissue, that is phloem. So here 4 different type of tissue will come together, that is sieve element. First there is a sieve element. Sieve element will comprise of sometimes sieve tubes, or sieve cell. Some plant has sieve tube and some has sieve cell. So rather we call them as a sieve elements. So sieve elements are sieve tubes and sieve cell. Then there is a companion cell. The name itself indicate they are companion. Then phloem, parenchyma and bast fiber or sclerenchyma. So rather these two elements, among these two elements, so this sieve element is mainly meant for having a transport of food. Companion cell will help this sieve element to transport the food. So companion, its name suggests, it will be only helping. So basically companions are going to maintain as a pressure gradient. Companions are meant for having maintaining pressure gradient in the cell. Then phloem, parenchyma, as usually we have considered phloem, parenchyma, rather in xylem parenchyma also they are responsible for storage of food. And here your bast fiber or phloem, sclerenchyma, they are used for mechanical support. And here their commercial importance is also there. So most important thing, you just remember, in gymnosperm there is a presence of albuminous cell and sieve cell. In gymnosperm there is a presence of albuminous cell and sieve cell. Instead, in gymnosperm there is the absence of companion cell and sieve tube. Most important thing which you have to remember, in gymnosperm companion cells are replaced by albuminous cell and sieve tubes are replaced by sieve cell. It means in gymnosperm there is a presence of albuminous cell and sieve cell, but there is absence of companion cell and sieve tube. So in gymnosperm companion cells are absent, and instead of that companion cell there is a presence of albuminous cell. In gymnosperm long elongated sieve tubes will not be present, but oval spherical sieve cells will remain present instead of sieve tube. So this sentence you have to remember. Here you could get a question. So in gymnosperm albuminous cells, or in gymnosperm companion cells are replaced by albuminous cell and sieve tubes are replaced by sieve cell. So this is important statement for you. Now we have to consider one by one these four tissues which are responsible for having actual conduction of or formation of phloem. So first element we consider it as a sieve element. So as I have told you, sieve element is comprised of sieve cell and sieve tubes. So here we are considering about a angiosperm. So in angiosperm there is a presence of sieve tubes and sometimes there is a presence of sieve cells as well. So these sieve elements, rather sieve tubes, are long, elongated and dead. They are long, elongated and dead. So as they are long, they are elongated, they are transversely placed, means they are placed one above the other. Likewise, each sieve element is arranged likewise. So one sieve tube, another sieve tube, then another sieve tube. So sieve tubes are arranged one above the other. So sieve tubes are long, elongated and they are dead. They are arranged one above the other in a continuous stream. They will form a continuous stream in the plant. So as like we consider here how they have been arranged. So your sieve tubes are arranged one above the other, like so this is one tube and this is another tube. So here there will be sieve plates. So they are joined. Here there will be likewise. So they are forming a continuous stream of water. And most important thing, here there is a presence of sieve plate which is having perforation. These sieve plates are having perforation. On this side there is a presence of companion cell. On this side there is a presence of, we'll draw a diagram. On this side there is a presence of companion cell, and here the transverse wall will have perforation. As this transverse wall will have perforation, so there is a primary exchange between your sieve tube and companion cell. So that's why we call them as a companion of each other. And the most important thing, your sieve elements or sieve tubes lacks nucleus. They don't have nucleus. They don't have nucleus. So it means who is going to regulate them? So your companion cell is going to regulate them. As sieve tube don't have nucleus. Sieve tube don't have its own nucleus. So your companion cell. Why sieve tubes are in a need of companion? Because they don't have a nucleus. So for that they will be in a need of companion. If you don't have a regulating authority, then you need to have someone in company of you. So here companion cell. So basically sieve tubes are primarily having a stream of food. As these tubes are completely hollow. These tubes are inner wall thickening is not present. Inner wall thickening is not present means they are totally hollow from the inner side. As in trachea and vessel, there was inner wall thickening. Here, inner wall thickening is not there, so it means they are completely hollow. And adjacent to them, there will be companion cell. So, sieve tubes are long, elongated and dead, and they lack nucleus. Comprised to sieve cells, they are not long, elongated. Sieve cell, we have called them cell, and here we are calling them as a sieve tube. So, likewise, they lack nucleus. So, as they lack nucleus, so they will be in a need of company, and that company will be provided by your companion cell. So, sieve tubes are primarily meant for having production of food. The lateral walls, sometimes the lateral walls of sieve tubes are perforated. Lateral walls of sieve tube are perforated. Here on this lateral wall, there is a several perforation. So, this perforation will maintain a cytoplasmic stream or cytoplasmic connection. Here, cytoplasmic connection between companion cell and your sieve tubes. So, this is because of this perforation. And here one sieve tube, another sieve tube has a connection, and that connection point we call it as a, they are obliquely placed. Likewise, there is a sieve plate. We call them as a sieve plate. These sieve plates are also having a large perforation. Sieve plates are having a large. Suppose here there is a food, and that food has to be transported here. So here in a sieve plate will be in need of perforation. That perforation will get transferred. Their walls are also thick. We consider there is a deposition of calories in their wall. So here perforations are present. So this is first issue, that is sieve tubes. We consider them one by one, and then we consider their organization. Then another component of your phloem, that is companion cell. Companion cell is going to have a most important. So initially we consider sieve tube is going to have a transport of food, but that transport is completely solely regulated by the companion cell. Means here authority is companion cell, working will be sieve tubes. Authority is companion cell. How companion cell managing? Because your sieve tubes don't have nucleus. So as they don't have nucleus, there will be no regulating authority. And so we have provided them as a companion cell. So these companion cells are most important in the phloem transport or transport of food. So companion cells are long, but they are sometimes narrow, or long, and we call them as a long and narrow. Their walls are thin. Companion cells are long, narrow, and their walls are thin. Then there is a they will be present lateral to the your sieve tubes. And we have considered this is our sieve tube, and on the lateral side of this sieve tube there is a presence of companion cell. So we consider companion cells are present lateral to the sieve tube. So companion cells are long, narrow, thin walled. They are present lateral to the sieve tubes. There is a presence of cytoplasm, dense cytoplasm inside a companion cell, and their nucleus is large, as they have to regulate companion cell as well as they have to regulate your sieve tube. So their nucleus is large. Nucleus is large in companion cell and nucleus is absent in sieve tube. So here your companion cell has dense cytoplasm and large nucleus, or prominent cytoplasm or prominent nucleus. They maintain a pressure gradient. Actually, if you have to have transport, then you have to create a pressure. You have to create a pressure. So that pressure gradient will be maintained by the companion cell. So companion cell is going to maintain a pressure gradient. There will be creation of pressure difference of food, and that pressure difference will be created by your companion cell. So it means companion cells are solely responsible for the. Here there is a presence of your sieve tube, and adjacent to the transversely or laterally to the sieve tube there is a presence of companion cell. So here there is a presence of perforation in these two walls. So this perforation will maintain a cytoplasmic stream in between them. So cytoplasmic stream or cytoplasmic connection is present in between companion cell and a sieve tube. So this cytoplasmic connection will create a gradient here. Will create a gradient. Suppose here there is the presence of your food in ample quantity. Here there is the presence of leaf. So leaf has transported food here. And already in your sieve tube, this sieve tube there is a food. But this food will be withdrawn and this food will gather here. So here if a food from this tube has entered to the companion cell, so here there will be creation of difference of food in between this tube and this tube. So there will be transport of food from this cell to this cell. So whatever the food we are present here, organic food we are present here in this sieve tube, that has been withdrawn by the companion cell. And as companion cell has withdrawn that food, from here there is a difference. Now here there is ample quantity of food and here there is a less quantity of food. So there has been created a difference, and this difference we call it as a gradient. So this pressure gradient of organic food is regulated or maintained by your companion cells. So companion cells are meant for maintaining the pressure gradient of organic food, and because of that pressure gradient, your companion cell is going to decide rather food will be, or the direction of food. The direction of transport of food will be regulated by the companion cell. So there is a cytoplasmic connection between companion cell and sieve tube. Why there is a cytoplasmic connection between companion cell and a sieve tube? Because there will be transverse pits, or there is a transfer perforation on the this wall, this transverse wall of your sieve tube. This transverse wall of sieve tube, there will be presence of, on this transverse wall of sieve tube, there is the presence of perforation or pit. This pit is going to maintain the cytoplasmic stemming or connection between them, connection between companion cell and sieve tube. And with the help of this perforation, your companion cell is going to regulate the activity of sieve tube, as there is a lack of nucleus. So here there is a connection, cytoplasmic connection between companion cell and sieve tube, and that is because of transverse wall. See, important thing about companion cell. Companion cells are absent in gymnosperm, and instead of companion cell in gymnosperm, there is the presence of albuminous cell, as we have considered here. Companion cells are absent in gymnosperm and they are replaced by the albuminous cell. As well, sieve tubes are absent in gymnosperm and they are replaced by sieve cells. So sieve tube element, here we comprise of sieve tube elements are tubes, or sometimes they are small cells. One tube connected, or they are placed one above the other. These two tubes are connected. Here there is the presence of sieve plates. Obliquely placed sieve plates are there, and these sieve plates are having a large size perforation. These sieve tubes are having perforation, and because of this sieve plate perforation, the food, organic food from this sieve tube will get transported or streamed to this sieve tube, and that is only because of a pressure gradient or gradient, whatever the difference will be set in between or in the quantity of food. So here your main two elements which are required for having transport of food are sieve tubes and companion cell. Now we have to consider another two elements, that is phloem parenchyma. So as we have considered two components of your phloem, that is sieve tubes or other sieve elements and companion cell, and there are two another components, that is phloem parenchyma and bast fiber or phloem sclerenchyma. So first of all we will consider a phloem parenchyma. So phloem parenchyma is normally the parenchymatous tissue which is present in a phloem, or which is organized in a phloem. These are, as we have considered before also in a simple parenchymatous tissue or simple permanent tissue, that is these are living, and as they are living one, so they are meant for their primary function is having a storage of food. Here in phloem, these phloem parenchymatous cells are intermingled. It means they are intermingled somewhere in between a sieve tube component. So they are intermingled with a sieve tube. So they are intermingled. First somewhere there is a intermingled sieve tubes inside a sieve tube. So phloem parenchyma are intermingled in a sieve tube. Then these phloem parenchyma are absent. Important statement for you. Phloem parenchyma are absent in monocots and some dicots. So phloem parenchymas are absent in monocots and dicots. Rutlow is so. Phloem parenchyma are absent in monocot and some dicots. Phloem parenchymas are absent in monocots and some dicots. So this is about phloem parenchyma. So phloem parenchyma, primary function of phloem parenchyma is having a storage of food. They are intermingled with sieve tubes, and these are living tissue, and they are absent in monocots and some dicots. Now we have to consider bast fibers or phloem sclerenchyma. So as we are aware about, sclerenchymatous tissue are long and elongated, having a lignified, thick walled lignified cells, and they are primarily mean for providing a mechanical support. So these sclerenchymatous tissue we have used here in phloem, so we call them as a phloem parenchyma, and as we call phloem as a bast, so we call him as a bast fibers. So they are absent. So when there is a presence of phloem in your leaf and root, so these bast fibers or phloem sclerenchyma are absent in leaf and root. And on the basis of development, the primary phloem and there is a secondary phloem. So these bast fibers are absent in the primary phloem also. So important thing, or here you could get a question, bast fibers are absent in a leaf, leaf phloem, root phloem and primary phloem, but they are present in the secondary phloem. So these secondary phloem which are present in, these bast fibers which are present in secondary phloem, they are having a commercial importance. They are used for making of ropes and textile material. So as like we consider jute here. So that jute. So that jute is a bast fiber from a secondary phloem, and bast fibers or phloem sclerenchyma are absent in primary phloem, but they are present in secondary phloem, and that second bast fiber which is present in secondary phloem has a commercial value. Bast fiber which is present in secondary phloem has a commercial value. They are used for formation of ropes and textile. So this is your bast fiber and this is your parenchyma. So overall, the component of phloem, that is your sieve tubes or other sieve elements, then companion cell, then we have considered phloem, parenchyma and bast fiber. Bast fibers are dead, as sclerenchyma is a dead tissue. So here also this sclerenchyma is still present in the phloem will also be a dead. So here only living tissue is phloem, parenchyma. So that's why we call phloem, parenchyma as a dead tissue, because all three components out of the four, three are a dead one and only your phloem, parenchyma is a living one. Rest of the three, sieve tubes, companion cell and sclerenchyma, they are dead tissue. So on the basis of development, your phloem is also considered as protophloem and metaphloem. Similarly, we have considered protoxylem and metaxylem. The early form xylem is called protoxylem, the late form xylem is called metaxylem. So here also we consider protophloem and metaphloem. The protophloem is the phloem which is formed early in the plant body. Which is formed early. Early means whenever the plant was small. That time the protophloem or the phloem which has been formed, we called it as a protophloem. Protophloem has a small tubes. Protophloem has a small size tube. Then the phloem which is late formed in the plant body is called metaphloem, and the metaphloem is having a bigger tube. See, as the plant is small one, so there is a very less need of food. So these tubes are smaller one. But if plant grows in the latter stage, definitely in the late phase of their life, plant will have enormously grown, and that enormously grown plant will be in a need of more food. So as there is a need of more food, so here your phloem needs to have bigger size tubes, and these bigger size tubes are present in the late form phloem, and we call that phloem as a metaphloem. Early form phloem is called protophloem, which has a small tube, and the phloem which is late form is considered as metaphloem, and they have a bigger tubes. So here we consider a diagrammatic presentation or diagram of your phloem, how phloem is going to organize in the plant body. So see, so sieve tubes, suppose this is sieve tube, this sieve tube, one sieve, this is your sieve plate, there, likewise, this is another sieve tube, here there is a presence of sieve plate, and here there is another sieve tube. So these are long elongated sieve tubes, and here on the either side, lateral side of your sieve tube, there is a presence of companion cell. Likewise, there is a presence of companion cell. And here on this side, there is a presence of, suppose this is your parenchyma cells. Say, these parenchyma cells somewhere there will be intermingled. And here, there is a presence of your phloem sclerenchyma. Like this. See, sieve tubes are placed one above the other. It means similarly as like xylem, they are going to form a continuous column. So here these sieve tubes are having completely hollow. There is no inner wall thickening. There is no inner wall thickening, and this is considered as sieve plates. Sieve plates, sieve tubes, bast fibers, and phloem parenchyma. Is there? And this is your companion cell. these companion cells are laterally present and your parenchyma cells are intermingled with the sieve tube. Here, this wall has a several perforation. This transverse wall has a several perforation, and with the help of this perforation, there is a presence of cytoplasmic connection between sieve tubes and companion cell. And here there is a presence of large size nucleus of your companion cell, and there is a dense cytoplasm. So this companion cell is going to maintain a pressure gradient. It is going to set a gradient, and with the help of this gradient, there will be, or this companion cell is going to define the direction of flow of food. Suppose here there is a presence of food, here there is a presence of food, here there is a presence of food, and on the sieve plate there is a presence of perforation. Sieve plates are also having perforation. So this perforation is going to maintain a stream of your food. Likewise, there is a presence of stream of food. So from here there is a food, it is connected. Likewise, here there is a food, it is connected. Like so, there is a presence of stream of a food, and this stream of organic food is going to transport one above the other. Next thing, suppose here there is a presence of leaf. So from leaf, it is connected here. Rather here there is a presence of leaf. So now food will be transported likewise. So direction of transport of food is defined by the companion cell. Either food is going to transport upward way or in a downward way. So this is all about your phloem. So phloem has a 4 component: sieve tubes, then companion cell, phloem parenchyma, and phloem sclerenchyma or vascular. So this phloem is primarily meant for having a bidirectional transport of food. We call phloem as a bus, we call phloem as a leptome. This term has been given by, or leptome, the term leptome has been used by Hubbard, as like we consider hard room for the xylem. So similarly we will call it here as a leptome. A phloem tissue is considered as a dead tissue. Is there? So these two complex tissue, in previous part we have considered xylem, and here we have considered phloem. So they are going to form a bundle. So one way there is a presence of xylem, and another there is a presence of phloem. So they will be present together, and they together will form a bundle. That bundle we called it as a vascular bundle. And this vascular bundle, in that vascular bundle, the xylem is going to transport or conduct the water, and phloem is going to have a transport of food. So the transport of food in phloem is bidirectional, and transport of water or conduction of water in xylem is a unidirectional. Is there? So I guess you understand it. And after completing this chapter, one by one we finish it, and later on I will give you the site where exactly you will be able to find the MCQ. So here in this anatomy of flowering plant, you will have a certain site where there will be a generation of MCQ always by the NCERT. So they will frame MCQ exactly at the certain location. So at the end we will have one more video which will comprise of only the site where you will find the MCQ.